Hello friends, I welcome you on this tutorial video on integration which we are going to evaluate by the use of partial fraction. I have taken this 4 example in this video and I have named the type of integral of this type as type 1. Okay, तो चलिए शुरू करते हैं. We are starting with the first example, that is integration of 1 by x square minus 4 dx. Okay, and we can write 4 as a square of 2, and if we expand the term in the denominator we will get here x minus 2 into x plus 2 dx. Now if we try to decompose this rational expression by partial fraction, we will get here 1 by x minus 2 into x plus 2. The decomposed partial fraction form of this will be look like a by x minus 2 plus b by x plus 2. If we take the LCM of the terms in the denominator, we will get here a into x plus 2 plus b into x minus 2 upon x minus 2 into x plus 2, which will be equals to 1 by x minus 2 into x plus 2. These terms are same, so I am rubbing them. Okay, now if you put x equals to 2, you can find the value of a, and the value of a would be equals to 1 by 4, and if you put x equals to minus 2, you can find the value of b, and b will be equals to minus 1 by 4. Okay, so in place of a I am writing 1 by 4, and in place of b I am writing minus 1 by 4. Okay, now this was the partial fraction form of this rational expression. If we integrate this rational expression, it will be equivalent to the integration of this. Okay, now we just need to integrate this. This will be equals to the integration of this rational function. So I'm taking this. That will be equals to, if we take 1 by 4 common, it will be 1 by x minus 2 dx minus 1 by x plus 2 dx, as the integration operator is. Now if you integrate this, you can get here the integration of this would be log of x minus 2, and the integration of this would be minus log of x plus 2, and we can write this as 1 by 4 log of, sorry, we can put here mod also, mod of x minus 2 divided by mod of x plus 2. Okay, so this is the evaluation of integral of this type by the use of partial fraction. Okay, we can also write this as a formula. If we have the expression like this, x square minus a square, it will be equals to 1 by twice of a log of x minus a by x plus a plus c. Okay, here you can also write plus c. Now taking the second example, which we also going to solve by the use of partial fraction. This is the second example, 2x plus 3 by x square minus 9 dx. 9 can be written as square of 3, and this can be written as x plus 3 into x minus 3. Now we need to find the partial fraction form of this, so I am taking this rational expression for finding the partial fraction of it, and I am doing it quickly. The partial fraction form of this would be a by x plus 3 plus b by x minus 3. If we take the LCM, we can have here a into x minus 3 plus b into x plus 3. If you put x equals to 3, you can get the value of b. B would be equals to 9 by 6. 9 by 6. So the value of b would be 3 by 2. and if you put x equals to minus 3, you can calculate the value of a. A would be equals to minus 3 by 6 minus 6. Okay, minus 3 by minus 6, that will be equals to 1 by 2. Okay, so b is equals to 3 by 2 and a is equals to 1 by 2. So the partial fraction of this would be a by x plus 3 plus b by x minus 3 dx. In place of a, we are writing 1 by 2, so I'm writing here 1 by 2. In place of b, we are writing 3 by 2. Okay, now bringing this integration operator is distributive, so this will be equals to 1 by 2 into integration of 1 by x plus 3 dx plus 3 by 2 integration of 1 by x minus 3 dx. Okay, so the integration of 1 by x plus 3 would be equals to log of mod x plus 3 plus 3 by 2 integration of this would be equals to log of mod x minus 3 plus c. So you can see here how quickly you can find the integration of such function by the use of partial fraction method. Okay, now I'm taking the third example, that is the integration of x minus 2 by x square plus 3x dx. Its partial fraction form would be a by, now first I am writing how you can write this rational expression as x minus 2 by, if you take x in the denominator common, you can have x into x plus 3 dx. Now you have to find the partial fraction of this function x minus 2 by x into x plus 3. The partial fraction of this function would be a by x plus b by x plus 3. If you take the LCM, I am doing it quickly, a into x plus 3 plus bx would be equals to x minus 2. Now if you put x equals to 0, you can find the value of a directly, and the value of a would be equals to minus 2 by 3. If you put x equals to minus 3, you can find the value of b very quickly, and b would be equals to 5 by 3. Okay, so I'm writing in place of a minus 2 by 3 and in place of b 5 by 3. Okay, now if you integrate this, it will be equal to integration of this, and the integration distributive, you can write this as like this. Okay, so this will be equivalent to minus 2 by 3 into integration of 1 by x dx plus 5 by 3 into integration of 1 by x plus 3 dx. Integration of 1 by x is log x, so this is minus 2 by 3 log x plus 5 by 3 log of x plus 3 plus c. Okay, now the fourth example that I am taking has a quadratic expression both in the numerator and the denominator, but you can able to find out its integration very easily. Now what I'm doing here, I'm adding minus 15 and plus 15 in the numerator. This will change this expression like this. Now in the numerator you will having x square minus 16 plus 15 upon x square minus 16 dx. Okay, now if we separate the terms like this, you will get here by x square minus 16 dx. Okay, this will be equals to 1. Now if you distribute the integration inside, you will get here integration of dx, 1 dx, and integration of this function. Okay, so the integration of dx is equals to x, and the integration of this function is, this can be written as 1 by x square minus 4 square dx, and the integration of this would be 1 by 2 into 4 into log of mod x minus 4 by x plus 4 plus c. 2 into 4 is 8, and 15 into 1 by 8, you can write this as 15 by 8. Okay, so this was the integration of functions like this. I have named this type as type 1. And don't forget to watch the second video in which we have taken another type of rational function, which we are going to also solve by the use of partial fraction method. We are naming them as type 2. I hope that this video will be helpful for you all, and if you are new on my channel, don't forget to subscribe. And अगर आपको वीडियो पसंद आया तो लाइक तो बनता है. थैंक यू सो मच.